Next up, we're going to look at some ways to display and analyze the data that we talked about in the previous video. And it says, for a finite number of possibilities, a table or graph may be a helpful way to represent the probabilities of a distribution. And we're talking about discrete variables here. Because if it's a continuous variable, you have an infinite number of possibilities between any two data points. So if it's going to be finite, it has to be discrete. So you can use a table or a graph, and we did this a pretty good bit back in chapter 5. We're going to do it a little bit more here with a new type of display, this probability display. So in example 1, this distribution is showing gender in a stats class. So we've got, is the person female, 0 or 1? 0 means it doesn't fit the criteria. So 0, not a female. And 1 means does fit the criteria. So 1 would be yes. Now note this is not numeric data. We saw an example like this back in chapter 2 or chapter 3, but the average here would not have a meaning. If you average the zeros and the ones, you would get something in between, like 0.6 or 0.4 or 0.5, and that doesn't have any label associated with it. So this will be categorical data because we're describing gender, male or female. However, we can see the probabilities from here. We can see the 0 probability, those that aren't female, goes up to 0.4. That's 0.40%. And the 1, those that are female, that's 0.6. I'll write it as 0.60, so it's 60%. And we can say, therefore, a randomly selected student will have a 60% chance of being female. We can use this table to show the probabilities. 60% are female, 40% are not. As well, we can use this graph to display our probabilities. There are only 2 possibilities here. So we used a table and a graph. If we go down a little bit further to example 2, we're going to go the opposite direction. We have the table. We want to create a graph from this table that illustrates the distribution of all Amazon reviews of the book. What is a p-value? So we've got 1-star reviews, 2-star reviews, 3-star reviews, 4-star, 5-star reviews. So we've got these limited number of possibilities, only 5 possibilities, so we can use this table, we can use this graph. Across the bottom here, I'll label this as the number of stars for that review. So we'll have 1 star, and 2 stars, 3 stars, all the way up to 5 stars. Along the side, I'll have my probability. Since this is in decimals, I'll do it in decimals as well. And note it goes from 0.05 or 5% all the way up to 0.35 or 35%. So there's no need to take this all the way up to 100%. I will just count by tens for E. So it'll be 0.10 or 10%. Here's 0.20. Here is 0.30. And then I'll just draw in my lines. 1 star was 0.05 or 5%. Take it up to here. 10% of the reviews were 2 stars. 20% were 3 stars. 30% were 4 stars. And finally, the highest review, 5 stars, 35%. So you can see this book must be pretty good. It's got a lot of the high reviews, very few lower reviews. Final question here. What is the sum of the probabilities for all possible book reviews? If you add up these decimals, the total is 1, which is the same thing as 100%. We've got the entire sample space taken care of with these 5 possibilities.